Hi, my name is Wayde Dazelle, and today I'll be presenting a paper by Gonzalez-Redondo et al. Entitled Gray Matter, Hypometabolism, and Atrophy in Parkinson's Disease with Cognitive Impairment, a two-step process. Historically, the pathophysiological process underlying the cognitive decline observed in Parkinson's disease has been poorly understood. Although cerebral atrophy and hypometabolism have been previously observed in cases of Parkinson's disease manifesting cognitive impairment of varying severity, the exact relationship between these events and the progression of said impairment remain unclear. The authors define cerebral atrophy as a reduction of gray matter volume, whereas they define hypometabolism, the underperformance of metabolic activities by cerebral tissues, by reduced uptake of FDG, as visualized by FDG PET, that is, fluorodeoxyglucose positron emission tomography. Fundamentally, FDG PET visualizes metabolically active lesions and malignancies, characterizing them by the extent to which they uptake the radiolabeled glucose analog. Note the images on the right side of the screen. The first is an example of a visual derived from PET scanning, whereas the second demonstrates the structure of the labeled glucose analog. This paper attempted to determine the extent and topographical distribution of hypometabolism and atrophy in cases of Parkinson's disease in an effort to elucidate the relationship between cognitive decline and the severity of these events, the ultimate purpose of which being to test the hypothesis that the neurodegenerative process leading to the development of dementia and Parkinson's disease is fundamentally a two-step process by which the reduction of FDG uptake, hypometabolism, precedes and ultimately exceeds the loss of gray matter density, atrophy. This study utilized a pool of 46 participants divided similarly between control, Parkinson's disease without cognitive impairment, Parkinson's disease with mild cognitive impairment, and Parkinson's disease with dementia. Note as well that the participants were older adults and that the severity appeals to the roughly scale of the age, as would be expected with a neurodegenerative condition leading to progressive cognitive impairment. Figure 5 demonstrates superimposed mean z-scores for hypometabolism and atrophy derived from MRI and PET scans of patients with Parkinson's disease and associated mild cognitive impairment or dementia. Overlap is observed in both cases. However, closer examination reveals that, although present in both cases, regions of hypometabolism, observed in red, and atrophy, observed in blue, are far more prevalent in cases with associated dementia than in those with mild cognitive impairment. Furthermore, atrophy appears to be far more prevalent in cases of associated dementia than in those with mild cognitive impairment. These images seem to suggest that in cases with associated dementia, the hypometabolic regions associated in cases with mild cognitive impairment are replaced by atrophy, with extensive hypometabolic expansion co-indicated. Interestingly, coincidence of hypometabolism and atrophy, itemized in yellow, was observed in the core hypometabolic regions of the occipital parietal junction and the frontal lobe, suggesting a transformative process occurring in the core regions. So what are the conclusions that follow? First, hypometabolism and atrophy manifest discretely and coincidentally. Second, hypometabolic areas and mild cognitive impairment are supplanted by atrophied structures which are further supplemented by a broad and expansive hypometabolic front. Third, there is a severity gradient associated with increased cortical changes. Finally, and most importantly, results seem to suggest that hypometabolism in Parkinson's disease predates and is ultimately replaced by atrophy in a progressive and expansive manner that is highly correlated with cognitive decline. This paper suggests that cognitive decline is progressive and is correlated with the death of neuronal tissue. This paper has the potential to inform not only our own understanding of the progression of this illness, but also to inform the development of therapeutics. Thus, it follows that recognition of the earliest cognitive changes that manifest in cases of Parkinson's disease may be critical in identifying penumbral areas for pharmacological targeting. Additionally, therapeutic interventions that target pre-atrophy hypometabolic tissues may be crucial to the recovery of dysfunctional brain regions prior to a definitive loss of gray matter volume and density, and ultimately, and most importantly, the irreversible development of dementia. These are my sources. Thank you for listening. Have a great day.